Hey guys, I am going to discuss assignment 5 B.Sc first year, and our topic is today's topic is Horner process and general transformation. So now in problem first, our given function. So let us consider the given function f of x is equal to 2 times of x to the power 4 negative 13 x square plus 10x negative 19. So now we need to find the value of f of x plus 1. So now, so to find f of x plus 1. So now here we can write as by comparing with f of x plus h, our value of h, that is 1. So now further, by using Horner process, we can construct synthetic division. We will solve the value of f of x plus 1 by using the synthetic division method. First of all, we need to draw this table and we need to write all the coefficient here. But you can see our given function f of x is not in terms of standard form. So we need to express this function in terms of standard form, that is 2 times of x to the power 4 plus 0 times of x to the power 3 negative 13 x square plus 10x negative 19, and write all the coefficient here, that is 2, 0, negative 13, 10, negative 19. So write the value of h here, that is a 1. Here will that is a 2. 2 multiplied to 1, it will give 2. On addition, it will give 2. 2 1 2, it will give that is a negative 11. And 1 multiplied to negative 1, that is give negative 1. It will give that is a negative 1. 1 multiplied to negative 11, it will give negative 11. On addition, it give negative 1. And after multiplying with 1 to negative 1, it will give that is negative 1, and that is negative 20. And this is our required value of a4. Again apply, right here, that is a 1, it will give 2, that is 2. 2 plus 2, that is a 4. Here will that is a 4, that is negative 7. Negative 7, it will give negative 8. So it will give that is a3. Again apply 1, it will give 2, that is 2. It will give that is 6, that is a 6, that is a negative 1. So this value is equal to a2. So now further, that is 1, here will 2, that is 2, 8, that is negative 8, that is negative 9. And this, sorry, we will not proceed here. We have to fix here, that is 8, and this value will be equal to a1. So now again apply 1, that is a 2. This value is equal to a0. So now further, the value of f of x plus 1 can be written, that is a0 x to the power 4 plus a1 x to the power 3 plus a2 x square a3x plus a4. Value of a0 that is 2 times of x to the power 4 plus 8 times of x cube negative x square and negative 8x, and that is negative 20. So we can say that this is our required value of f of x plus 1, and this is our required final answer. Now in problem 2, so now let us consider the given equation, that is x to the power 3 negative 6x square plus 15x negative 1 is equal to 0. That is the given equation. So in this problem, it is given that by diminishing the root of given equation by the suitable number, and this suitable number is unknown for us, and we have to form the equation in which the coefficient of the second term is 0. So now, first of all, we need to assume that alpha comma beta and gamma be the roots of the given equation 1, and these roots are diminished by suitable number. Let us suppose that is a h. Then roots of the required equation that is unknown for us, that is f of y is equal to 0, will be, that is alpha negative h, beta negative h, and gamma negative h. So now the sum of roots of equation 1 is equal to negative of negative 6. So now here alpha plus beta plus gamma is equal to 6. So we can say that alpha plus beta plus gamma is equal to 6. And let us suppose this equation is 2. And the sum of roots equation f of y is equal to 0. This value is equal to sum of roots of the new equation will be 0, because second term is 0, means coefficient of second term, that is a 0. We can say that the coefficient of second term is 0. So by using that, we can write here alpha negative h plus beta negative h plus gamma negative h is equal to 0. From here, alpha plus beta plus gamma negative 3 times of h is equal to 0. So now from here 6 negative 3h is equal to 0. So therefore we can say that value of h is equal to 6 over 3, that is 2. So now here we can assume that our y is equal to y is the root of the required equation, that is x negative alpha, sorry, x negative h, that is we can write x negative 2. So now from here we can find the value of x, that is y plus 2. So now we need to find the equation f of y plus 2. So now by using Horner method, we can find the value of f of y plus 2 by using synthetic division method. Write all the coefficient here, and that is 1, negative 6, 15, negative 1. That is 1, negative 6, 15, and the last coefficient, that is negative 1. That is negative 1. So now from here, right here, that is a 2. By comparing, we can find the value of s, that is 2. And here will be, that is a 1. 2 multiplied to 1, that is a 2. That is negative 4. 4 to 2 multiplied negative 4, that is negative 8. Here will be, that is 7. 7 multiplied to, that is 14. That is a 13. This value is equal to a3. Again we have, that is a 2. Here will be 1. 1 multiplied to, that is a 2. Here will be negative 2. That is a negative 4. Here will be 3. This value is equal to a2. So now further, here will be 2. That is a 1. That is 2. It will give 0. And that is a1. So now further, again right here 2. It will give, that is a 1. And this value is equal to a0. So we can write here our required, therefore the required equation f of y plus 2 is, that is a0 y to the power 3 plus a1 y square a2y plus a3, and that is we can write here a3 is equal to 0. So now the value of a0, that is 1, a cube, this becomes 0, and value of a2, that is a 3. It will give, that is a 3y plus 13 is equal to 0. So this is a very required equation, and this is a very required final answer. Now in problem third, so let us consider the given equation, that is x to the power of 3 plus qx plus r is equal to 0. That is a given equation. So now in this problem, it is given that alpha, beta, gamma are the roots of the given equation. This x cube plus qx plus r is equal to 0. So we need to form the new equation whose roots are 1 upon alpha plus beta, 1 upon beta plus gamma, 1 upon gamma plus alpha. So from equation we can find the sum of root, that is summation of alpha, that is alpha plus beta plus gamma is equal to 0. That is equation number 2. Second is summation of alpha beta, this is equal to alpha beta plus beta gamma, and gamma alpha is equal to negative q. Sorry, it will give that is a negative, it will give that is a positive q. Here will that is a 3, equation number 3. And third one, that is the alpha, beta and gamma is equal to negative r, that is equation number 4. So now first of all we need to assume that let y is equal to 1 upon alpha plus beta. So now here it, it can be written as here alpha plus beta missing, that is a gamma, so we need to adjust the gamma here in the denominator, that is alpha plus beta plus gamma negative gamma. So now here sum of root from equation 2 it could become a 0 negative gamma, but gamma is the root of the equation f of x is equal to 0. So that is the value of x, that is a gamma. So we can replace the gamma by x, that is negative 1 by x, and it can be written as that is value of x equal to negative 1 by y. Further we need to put the value of x, that is negative 1 by y, in equation first. Then it will be that is negative 1 by y to the whole power 3 plus negative 1 by y multiplied to q plus r is equal to 0. So here it will be that is negative 1 upon y to the power 3 negative q over y plus r is equal to 0. So by taking the LCM on left hand side, the LCM will be y to the power 3, higher order of y will be LCM. So that is able, that is negative 1 negative q times of y square plus r time of y to the power 3 is equal to 0. Here will be the r times of y to the power 3 negative q times of y square negative 1 is equal to 0. So therefore the required equation will be that is r times of y to the power 3 negative q times of y square negative 1 is equal to 0. And this is our required final answer. So now in this problem 4, the given equation is x cube plus px square plus qx plus r is equal to 0. So now we need to form the equation whose roots are alpha upon beta plus gamma negative alpha, beta upon y, gamma plus alpha negative beta, gamma upon alpha plus beta negative gamma. So first of all we need to consider the given equation, that is x cube plus p times of x square plus q of x plus r is equal to 0, that is equation number 1. So from here we can and also it is given that alpha comma beta comma gamma are roots of the given equation. So by using that we can find the sum of roots, summation of alpha, that is negative p, that is the equation number 2, and summation of alpha beta, that is q, that is equation number 3, and third one, that is alpha beta gamma, that is negative r, that is equation number 4. So now further we need to assume that, let us suppose, because we need to find the new equation whose roots are this, whose roots are these. So now we need to assume let y is equal to alpha upon alpha plus beta negative gamma. So now sorry, here will be that is alpha upon that is beta plus gamma negative that is alpha. So now here we need to adjust here. So we can write alpha upon alpha plus beta plus gamma negative 2 times of alpha. So by using 2, the sum of roots that is negative p, alpha upon negative p negative 2 times of alpha. But we know that alpha is the root of the given equation f of x is equal to 0. So we can replace the alpha by x. So now here we can write the value of y is equal to alpha upon negative p, sorry, that is x upon negative p negative 2 times of x. So now express the x in terms of y. So now the cross multiply, that is y times of negative p negative 2 times of x is equal to x. So now from here open the bracket, that is p times of y negative 2xy is equal to x. So now here take this term to the right hand side, that is negative p multiplied to y is equal to 2 times of xy plus x. So now from here negative py is equal to, take the x as a common, then we have 2 times of y plus 1. So from here we can find the value of x, that is negative py over 2y plus 1. So now we need to substitute the value of x in the given equation. So now we need to put the value of x, that is negative py upon 2 times of y plus 1 in equation 1. Then we have replace the value of x in by the term negative py upon 2y plus 1. So it will give, that is negative py upon 2y plus 1 whole cube plus p times of negative py upon 2y plus 1 whole square plus q times of negative py upon 2y plus 1 and plus r is equal to 0. So now from here, that is, because negative to the whole power 3, that is odd, it will give negative 1 multiply to p to the power of 3 y to the power 3 over 2y plus 1 to the whole power 3. Here that is p times of p square y square over 2y plus 1 to the whole square and negative p times of q y over 2y plus 1 plus r is equal to 0. Further simplifying this, we have negative p cube y cube over 2y plus 1 whole power 3. Here will be p to the power 3 y square over 2y plus 1 whole square negative p times of q times of y over 2y plus 1 and plus r is equal to 0. So now by taking the LCM of denominators of all term, its LCM will be, that is 2y plus 1 to the whole power 3. Here will be, that is a negative p to the power of 3 y cube plus p to the power 3 y square, and here will be that is a 2y plus 1, and that is negative pq y, and here will that is a 2 times of y plus 1 whole square, and plus r times of 2y plus 1 whole power 3 is equal to 0. So now after the cross multiplication, we can write this term as a first, that is r times of 2y plus 1 to the whole power 3 negative pqy 2y plus 1 whole square plus p to the power 3 y square 2y plus 1 negative p to the power of 3 y cube is equal to 0. So now simplify this term. Further simplifying, we will get that is, so that is a plus b to whole power 3, that is a cube plus b plus 3ab, that is 6y multiplied to 2y plus 1. Further pqy a plus b whole square, that is a 4y square plus 4y plus 1, and here will be that is after opening the bracket it will give that is 2 p cube y cube plus p cube y square negative p cube y cube is equal to 0. So now open the bracket here, it will give 8r y to the power 3 plus r, here will be that is 6 to the 12 y square multiplied to r, that is 12 r y square, that is 6y multiplied to r, that is 6yr. Here will be that is the 4 times of p cube y to the power 3 negative the 4 times of p cube y square negative p cube y plus 2p cube y cube plus p cube y square negative p cube y cube is equal to 0. So now collect the like terms, collect all the coefficient from the like term, that is the here, that is the y cube y cube y cube and y cube. So now here will be that is 2 times of 2p cube and p cube. So here will be that is 8r, and here that is negative the 4 times of p cube plus 2 times of p cube negative p cube y cube. Now collect the coefficient of y square, that is 12 times of r, that is negative 4 times of p cube, and that is plus p cube y square, and collect all the coefficient of y, that is a 6r, and that is negative pq y, and collect all the constant remaining, that is the r, and only r is that. So further simplifying, we will get 8r negative 4 times of pq plus pq multiplied to y plus, here will be 12 times 12r negative 4 pq plus p to the power 3 y square plus 6r negative pq multiplied to y plus r is equal to 0. So this is our required equation, and this is our required final answer. Now in problem 5, the given equation is x cube plus qx plus r is equal to 0, and alpha, beta, gamma are the roots. So we need to find the equation whose roots are alpha square, beta square, gamma square, and gamma square, alpha square. So first of all, we need to consider the given equation, that is x to the power 3 plus qx plus r is equal to, that is equation number 1. So now we can find here summation of alpha, that is 0, and second alpha beta, summation of alpha beta, that is positive q, and that is alpha beta gamma, that is negative r. This is equation number 2, that is equation number 3, and that is equation number 4. So now let y is equal to alpha square beta square be the root of the required equation. So this can be written as alpha square beta square. Here the gamma square is missing, so we need to adjust the gamma square in numerator and denominator. This can be written as alpha beta gamma to whole square over gamma square. So now further we can write here, that is y is equal to negative r to whole square upon gamma square. So this value is equal to r square upon gamma square. But gamma is the root of equation, given equation f of x equal to 0. So we can replace the gamma by x. So here will be, that is the value of y is equal to r square upon x square. So that is, we can write x square is equal to r square upon y. So now here take the root on both sides, the value of x, that is r upon root y. So now we need to put the value of x in the given equation. So now further we need to put the value of x, that is r upon root y in equation first. Then our equation will be, that is x cube, that is r upon root y to whole cube plus th that is r upon root y multiply to q plus r is equal to 0. First of all, simplify the first expression. It will give r cube, and here will be root y to the whole power 3 plus r cube over root y plus r is equal to 0. So now taking the LCM, so its LCM will be, that is y root y. Here will be r to the power 3 plus divide the y root y by root y. It will give r cube times of y plus, here will be, that is r y root y is equal to 0. So now further simplifying, it will give, that is cross r cube plus, that is r cube y is equal to negative r y root y. Okay. So now further simplifying, it will give r to the power 3 plus r cube y plus r y times of root y is equal to 0. So here will that is r to take the r as a common. So it will give that is r square plus qy plus y root y is equal to 0. So it will give that is r square plus q times of y plus y root y is equal to 0. But we know that equation cannot having the power as a radical. So we need to write as r square plus qy is equal to negative y root y. Now take the whole square on both sides. After taking the whole square, radical will be removed. So here will be that is r to the power 4, a plus b to the whole square will give r to the power 4, q square y square plus 2 times of q y r square is equal to y root y to the whole square, it will give y to the power 3. We know that y root y, that is y to the power 3 by 2. So after taking the square, that is y to the power 3 by 2 the whole square, it will give that is y cube. So that is our rough work. So after we can write in the standard form, take the all this term in the right hand side, and we can write here that is y to the power 3 negative q square y square negative 2 times of q r square y negative r to the power 4 is equal to 0. So this is our required equation, and this is our required final answer.